The one is to find the approximation of a given function by using Taylor polynomial, to write the computer representation of a number, and to study several types of error that occurs when solving using numerical methods. Okay, so these are the content that we're going to look at. Okay, and then we also have the introduction. Okay, numerical methods are important in scientific computing because they allow us to estimate solutions to problems that can be extremely difficult or impossible to solve precisely. Okay, that's why we need numerical methods. Okay, there are so many methods you'll be learning based on what types of problem you want to solve. Let's look at some of the preliminaries. Okay, we need to know about norm. Okay, we have one norm, two norm, and infinity norm. Okay, norm are used to measure the magnitude of a vector. Mathematically, a norm is a total size or length of all vector in a vector space of matrices. There are three types of norm. Okay, we have norm 1, norm 2, and norm infinity. It's for a vector. And if we have a matrix, we can also find the norm. Example for this given matrix A. The one norm, which is the A norm, is given by this definition. It's a maximum absolute column sum. Maximum absolute column sum. Okay, and if you have infinity norm, it's a maximum absolute row sum. This is for infinity norm. And then if you have two norm, okay, it's also known as Euclidean norm, which is used as a standard quantity for measuring a vector difference. So to get two norm, you need to get the square root of the eigenvalue with the A transpose multiplied with A and find the maximum of it. Okay, let's look at one example. Okay, so let's say we have this matrix A equals to 3, 5, 7, 2, 6, 4, 0, 2, 8. This is my matrix A. Now the question says find the norm of one norm, the infinity norm, and also the two norm. Find all this. Okay, so we want to know how to find this. So what is the A one norm here? Okay, it is a maximum column. Okay, this is the column. Let me just highlight. This is your column 3 to 0. So you want to find the maximum. Okay, you need to have absolute value of that. So 3 plus 2 plus 0, comma 5 plus 6 plus 2, comma 7 plus 4 plus 8. There are three columns, 1, 2, 3. Okay, and then maximum of, so we have 5, comma 13, comma 19. Now which one is the maximum? Maximum is 19. Okay, that's to find the one norm. Now to find the infinity norm, A of the infinity norm. So the same thing, but we want to look at the maximum of row. Okay, this is your row, this is your column. Okay, the row will be maximum of, okay, we have 3 plus 5 plus 7, comma 2 plus 6 plus 4, comma 0 plus 2 plus 8. Okay, now what you do here, you find the maximum of this. So this is 12, 13, 14, 15, 10, you have 6, 7, 8, 12, and then you have 10. So the maximum of this will be 15. Okay, we need to learn how to find this, because this will be useful to find the convergence of a method next time in the future. So you need to do this. You need to know how to do this, okay? Now there is also, this is a bit slightly complicated. We call the 2 norm. The 2 norm. Now to find the 2 norm, okay, the definition is the maximum, okay, maximum of the eigenvalue multiplied with A transpose A. This is the definition. Okay, where I can be from 1 to n. Depends. For this case, depends on our matrix here. Okay, so your matrix A is given as, okay, I'm going to write it again, 3, 5, 7, 2, 6, 4, 0, 2, 8. This is matrix A. Now what is A transpose? Okay, A transpose is the row will be column. Okay, 3, 5, 7 will be column, row will be column, 3, 5, 7. 2, 6, 4, second row will be a column, 2, 6, 4. 0, 2, 8, the third row will be my column. Okay, this is A transpose A. Okay, so it's say we need to find, before you find the square root, we want to find lambda A transpose A. Okay, lambda here is the eigenvalue. Sorry, I cannot write like this. Okay, let's find the A transpose A first. So meaning 3, 5, 7, 2, 6, 4, 0, 2, 8 multiply with 3, 2, 0, this one, 5, 6, 2, 7, 4, 8. Okay, so when you multiply with this 2, okay, I'm hoping you have a calculator so that it can help you to calculate quickly. So the answer that you should get is 13, 27, 29, 27, 65, 75, 29, 75, 129. Okay, so this is what you get. Now what we want to do is we want to find the dominant. Want to find the dominant eigenvalue. Okay, the dominant eigenvalue. So we have to find the eigenvalue first. So to find the eigenvalue, minus lambda I. Okay, A transpose A minus lambda I. So we have, this is the A transpose A, right? This is the one you found earlier on. You have 13, 27, 29, 27, 65, 75, 29, 75, 129 minus lambda, and this is your identity matrix 0, 0, 0, 1. Okay, don't forget the absolute sign here. Okay, and then what happened? You just continue to find this. So I have 13 minus lambda. We have the absolute here. And then 27 minus 0, 27. 29 minus 0, 29. Then I have 27 minus 0. 65 minus lambda times 1 is lambda. So I have 65 minus lambda. This is 75. 29 minus 0. This is 75. This is 1 to 1 minus lambda times 1 is lambda. 129 minus lambda. Okay, we have this now. Okay, this is what we have obtained when you minus that. So, to find this, you have to let it equal to 0. How do you find eigenvalue? You let this equation equals to 0 and get and solve for this matrix. Okay, you'll find the determinant. How to find the determinant? Let me just recall. To find the determinant, okay, that's what the symbol here means here. Okay, this symbol here means, I'm going to use different color. Okay, it's not coming. Okay, now you come. Symbol here stand for, this stand for also determinant of a matrix. Okay, so don't forget the positive sign. Positive, negative, positive, negative, positive, negative, positive, negative, positive. So just pick one column or one row. So I'm going to pick this one. This one. Okay, so I have 13 minus 7. Okay, so cross out 13 minus 7. I have this one. Okay, 65 minus lambda. 75, 75, 129 minus lambda. And then the second one is this one, negative 27. Now if you cross out negative 27 like this, right? Like this, right? So I have 27, 29. And then I have 75. I have 129 minus lambda. And then plus 29. Now, if I cross out 29, I have like this, right? So, if you're not sure what I'm doing, I'll cross out like this, 29. So, I have 27. Okay, I have 27. 65 minus lambda, 29 and 75. Okay, so if you look at this matrix here, you have to solve it when it's equals to 0. When it equals to 0. So, sorry, this is not 7. This is lambda. I don't know what I'm writing nowadays. Okay, so pardon me. This is lambda. Okay, I have lambda. Now, how do you find the determinant? So, this times this minus this times this, right? So, I have, I can remove my determinant symbol. Okay, because I'm trying to solve it. So I have 67 minus lambda multiply cross 129 minus lambda minus 75 squared. Okay, minus 27. What is this? 27 times this 129 minus lambda minus this 2 here. Okay, this is what I'm doing. 75 minus 29. Okay, and then next will be 20 plus 29. 27 minus, sorry, plus 27 multiply, not plus, 27 multiply with 75 minus this thing. 65 minus lambda multiply with 29. Okay, so you have to solve this one now. Okay, I need to use some tool, some calculator or anything. Okay, so now we expand this. So we have 13 minus lambda. It's not 7. 13 minus lambda, and then you expand this times this, this times this, and so on. Okay, we have 8385 minus 65 lambda plus 129 lambda, and then plus lambda minus 75 squared is 5625. Okay, so now we have minus 27. Now similarly, 27 multiplied with 129. So I have 3483. Now 27 minus lambda, 27 lambda minus 75 times 29, 2175. Okay, the next one is this one, plus 29 times 27. Maybe we can multiply that later. I'm just going to write 29 here. 27 plus 75. 2025 minus 29 times 65. 1885. 29 times lambda, negative 29 lambda, but then we have a negative here, it will be positive 29 lambda. Okay, so all these are continuation. Okay, now I don't have space, so I'm writing it minus here, but they are continuation. Okay, so now let's multiply, expand this multiply with this, and then so on. So maybe we can simplify this one first. Let's do that first. So 13 minus lambda, let's simplify this. This minus this, what we have? 2760 minus negative 65 plus 129. 194 lambda plus lambda squared. And we have minus 27. And we have 383 minus 2175, 1308 minus 27 lambda. Okay, and then plus 2025 minus 18. Okay, 2025 minus 1885. I have 140 plus 29 lambda. Okay, yeah, almost there. Hang in there, guys. Just have to expand it now. Okay, now we have to expand this. Okay, this multiply this, and then we have 13 times this, this times this, and so on. So let's do this. So we have 35880, 2760 times 13. Minus 194 times 13, 2522 lambda, 13 times lambda squared. Okay, this thing. So we have plus 13 lambda squared, and then this one minus 2760 lambda, and then negative negative positive plus 194 lambda squared. This with this, negative lambda cube. Okay, and then this with this, minus 35316, negative negative positive 729 lambda, 20 plus 29 times 140, 4060, sorry, we have 4060, and then plus 29 squared, 29 times 29, 841 lambda. Okay, this is a very long calculation. If you have any solver that can help you to find the eigenvalue, please feel free to use it. Okay, now I'm gonna what do you do? How do I do? Okay, 35880 minus 35316 plus 4080. So I should have 4624, and then negative 2522 lambda minus 2760 lambda plus 729 lambda plus 841 lambda. I should have minus 3712 lambda. Now I have calculated this earlier on a paper, and I'm just copying it actually, so please check. So 13 lambda squared plus 194 lambda squared. I have 207. Okay, and lastly minus lambda 3. Cool. So this is what we get. Now we have to solve for lambda, which is your eigenvalue. Okay, I can use a simple tool here. See, it's in the form A, B, C, D. A is the lambda, the highest power 3. So if I check, it was minus 1. Okay, This is my A, this is my B, this is my C, this is my D. So I have negative 1, 207. Okay, let's do this. I have negative 1 and my B is 207, and then my C is negative 3712, negative 3712, and lastly my D is 4624. 4624. Okay, so you can use this called cubic equation calculator. Okay, anything to the power 3, I can use this equation. Okay, calculate. Let's see what we have. There you go. You have x, which is in our case is lambda. Okay, 187.31489, 1.34607, 1833904. Okay, let's check the slide. There you go. Therefore, solving for lambda gives lambda equals to 13461. We have it. We have it here. And then we also have 18.3390. We have it. Okay, it's given up to 4 decimal places. And then we also have 187.3149. There you go. Okay, so we have got the solution. Okay, we have found the solution for lambda. So please know that what you want to find is the maximum to find A2 norm, where you take the maximum lambda, whatever lambda that you have obtained just now, where I have 187.3149, I have 1.34607, and then I also have 18.33904. Okay, oops. Okay, so what's the maximum number here? Okay, we find the square root of the maximum. Okay, gotta find the square root of the maximum. So the square root of 187.3149. This is the maximum value here. That will give you to the solution. What is the solution? I cannot see it. Let's zoom in. Okay, the solution here is 13.6860. If you can see, I don't know why I have this thing here. I don't know how to remove it for now. So there you go. There you go, 13.6863. So that is your solution. 63. Okay, so this is how you find the A2 norm. Okay, you can use the cubic equation calculator to find the A2 norm. Okay, and then the next what we want to do is to know about diagonally dominant matrix. Okay, so what is say here? N by n matrix is strictly diagonally dominant if the absolute value of each entry on the main diagonal is greater than the sum of the absolute value of the other entry in the same row. Okay, it must be the absolute of the entry. So for example, this question here, which of the following system of linear equation has a strictly diagonally dominant coefficient matrix? Which one has a strictly diagonal dominant coefficient matrix? So look at the solution here. It's not that complicated, okay? So for matrix A, we can write it as 3, 5, negative 3, negative 3, negative 1, 2, 5. Let's see. 3, negative 1, 2, 5. That's right. And then we can see that the diagonal, all the diagonal entries are 3 is greater than negative 1 and 5 is greater than 2. So we call it strictly diagonally dominant. Okay, now for the other problem just now, it gives 4, 2, negative 1, 1, 0, 2, 3, negative 5, 1. Okay, that's in the matrix form. There you go. 4, 2, negative 1, 3, negative, no, not that one. This one. 4, 2, negative 1, 1, 0, 2, 3, negative 5, 1. Okay, so this is not strictly diagonally dominant because of the value here. 4 is greater than absolute of this, absolute value of this. Yes, correct. But 0 is not greater than 2. Okay, and so does this 1 here is not greater than the absolute value of 5. So this is not strictly diagonally dominant. However, you can swap my row 3 with row 2 to get it strictly diagonally dominant. Interchanging the second and the third row in the original system of linear equation produces the coefficient matrix like this, which is strictly diagonally dominant. You can check the dominant, take the absolute value. You can see that 5 is greater than 3 and 5, 2 is greater than 0 and 1, 4 is greater than 2 and 1. So we have a strictly diagonally dominant matrix. Okay, so that's all for today, mathematical preliminaries. So we'll look my next video on Taylor series and the rest of the numerical method. Okay, thank you for joining me. See you next time.